Welcome to Spring LIB.
Okay, so we're doing chapter 29, problem 23. So in this problem, we have a loop with a radius r, and this is in a B field that is into the page of B. Okay, and it's uniform across the whole time. So they give us r being 0.025 meters, and they say this has a resistance big R of 0.39 ohms. Cool. So it says the magnetic field into the plane of the figure at time equals 0 equals 0. Okay, and then it follows a function b of t equaling 0.38 times t cubed. Okay, cool. So if we're looking for the induced current, we need this to be the induced EMF from the B field, the changing flux, divided by the resistance. So this becomes 1 over resistance times, using Faraday's law, this is the change in flux. And we'll just go with the absolute values here because we'll figure out which direction this is using the right-hand rule after this. Okay, so flux we also know is just the area times this. So we can rewrite this as pi r squared over big R times dB dt. But now we have an equation for t, or b of t, a function for it, so we can also just evaluate that. So let's say this also equals pi little r squared over big R, and this is times 3 times our constant factor 0.38, and this is t squared when we take the derivative. Cool. So it also says we need to know at the instant when B equals 1.33 teslas. So we got to figure out what time that is. The way we do that is taking the cube root of 1.33 over 0.38, and that gives us 1.518. Cool, so that's the time we want to evaluate our current equation at. So we know that the induced current magnitude is pi r squared over r, 3 times 0.38 and times 1.518 squared. If we put that all in our calculator, we see this comes out to 0.013 amps. Okay, so now we got to figure out the direction of this. So we have a flux that is into the page, and we also know that it is increasing with time. So Lenz's law says that the B from the induced current must be opposing the change in flux. So if it's into the page and increasing, we know that this must oppose that change and be out of the page. So now using the right-hand rule, we got to figure out what current clockwise or counterclockwise produces a B field out of the page. And if you use the right-hand rule, you'll see that that is counterclockwise. So this is our magnitude and direction of our induced current. Awesome.